What you will see in this video is the design of a smart home GUI demo powered by the STM32F7 Discovery Board, a control panel to monitor your hall and kitchen, control appliances like the hood and the oven, keep track of your bathroom environment, and control the exhaust fan, all inside one sleek, interactive IoT smart home interface. So don't miss this video. When the system starts, you are monitoring the hall. An animation appears, prompting you to choose whether to monitor the kitchen or bathroom. If you select to choose the kitchen, you can go back to hall whenever you want. And when you are monitoring the kitchen, you can control the hood. By this slider, you can choose the speed of the hood's fan. And by this key placed here, you can freely turn the hood's fan on and off. It features a charming and stylish design. By going back to kitchen, we can control the oven as well. You can set the temperature of the oven by these tiny keys placed here. You could also turn the lights of the oven on and off by this key here. And you could tell the oven to bake your foods by this button here. By returning to hall, you could monitor the bathroom as well. This digital key here is for controlling the exhaust fan of the bathroom. You could also monitor the temperature of the bathroom as well. And this is my design, my graphical user interface design for Internet of Things application. Let's see how I designed it. Before explaining the design procedure, I would like to tell you that the source code and all project files are available in my GitHub repository, and the link is provided in the comment section below. You can use this code if interested. First, I created a screen and I called it Hello Screen. Let's check the components of this screen. First, I added an image to this screen. You can find it from here. And I called it Hall. And I selected an image for it, which is this image. In fact, this microcontroller must be connected to real cameras, but as long as this is just a GUI demonstration, I've used images for this project. The important thing about this image is that it is 480 by 272 pixels, so it matches the LCD of the STM32F7 Discovery Board. You can access all the images in TouchGFX folder, Assets, Images. These are all the images that I've used in my project. Next, I created a button, which you can find it here, and I called it Bathroom Button. I selected two images for this. One of them is for when it is pressed and the other one is for when it is released. One of them is darker than the other one. I set the alpha to 0, so initially this button is not visible, and then I've checked fade animator and move animator boxes for these buttons because I'm going to create an animation for these buttons. The same thing is done for kitchen button. A button is created and it is called kitchen button. Two images is used for it. One of them is for when it is released and the other one is for when it is pressed. When it is pressed, the key is a little bit darker than the other one. I've set the alpha to 0 for this one as well. And I've checked fade animator and move animator boxes. Then after generating the code, I was able to go to STM32 CubeIDE via this button, then going to project folder, STM32 CubeIDE, and I could select the project. Then I went to application, user, GUI. I selected HellScreenView.cpp. I went to HPP file by pressing Ctrl and selecting these includes. You can go to the files. I declared a virtual void here and I called it handle tick event. It is used for updating animation. In the CPP file, I included this header file defines. It is in fact st_defines and I've used it in my project. For example, it includes half fade duration, which is set to 90 in this defines.hpp file. You could use these defines which exist in my project. To do that, you need to navigate to TouchGFX GUI, include, common, and here is the define HPP file. I've also included stdlib.h file. It is used for ABS function, which you can calculate the absolute value of numbers. Then this piece of code is added to this section. Button move callback, it is used for callback for moving animation. Button fade callback, which is the callback for fading animation. A variable for counting the ticks, and it is initialized with 0. And another variable which is used for animation speed, and it is initialized with half pixel per tick. It is the speed of the animation. It moves half of a pixel in each tick. Then these codes are added to this section. It is for fading the button. This function is declared here. It is used for moving the position of the buttons. And this function is responsible for moving the buttons after they fade in the animation and in the whole screen. This function is responsible for handling the tick events. And this function is used for setting the speed of the animation. You could change it if interested. And by using these codes, I created the animation that you are faced with whenever you start the GUI. Then I created another screen and I called it kitchen screen. As before, I placed an image here which is called kitchen PNG. This picture. I've created a button here and I called it return button. It is used for going back to whole screen. I've created an invisible button on the oven and I've set the alpha to 0 so it is not visible, and by touching it we will go to oven screen, a hood screen. Again, I've set the alpha to 0 so it is invisible, but by touching this area you will go to hood screen, and in that screen you can control the hood. And here are the interactions that I've set for this screen. The first one is return to kitchen, and the trigger is button is clicked, and whenever the return button is clicked, it changes the screen and goes to whole screen. Its transition is set to a slide and it moves towards west. The other interaction is called go to oven. The trigger is set to button is click. Oven button is our button source, and it changes the screen and goes to oven screen. The transition is set to a slide and it moves towards east. The same thing is done for the hood button, whenever it is clicked, the screen is changed and it goes to HUD screen. Transition is set to a slide, and the transition direction is towards north. I think I forgot to talk about the interactions of this image. There are just two interactions. One of them is go to bathroom. Whenever the bathroom button is clicked, it changes the screen and goes to bathroom screen. The transition is set to a slide and the direction is west. Almost the same thing is done for kitchen button, and whenever it is pressed, it goes to kitchen screen, which we saw it earlier. I've also created a screen and I called it bathroom screen. Here you can monitor the bathroom and control the exhaust fan. An image is placed here, which is this image. Another image I've added here, I wanted to indicate that this button is controlling for the exhaust fan. A flex button, which is invisible, and by use of it we will go to fan screen and control the exhaust fan, and a return button for returning to bathroom screen. And here are the interactions. The first one is return to hall, and the other is go to fan. The trigger is set to button is clicked. Whenever the flex button 1 is clicked, which is this invisible button, whenever it is clicked, it changes the screen and it goes to fan screen, and I've set the transition to block. The other screen is the HUD screen. I've set a box here and I set its color to gray. It is our background color. A return button is set here. For every screen, I've created a return button to be able to go to previous screen. A toggle button is set here. It is for turning the HUD's fan on and off. For when the button is released, I've set the image to this one, and whenever it was pressed, I've set the image to be this one. I've placed a slider for controlling the speed of the HUD's fan. I've set the type to vertical, an image for the background, and a filler image, and an image for the indicator, which is this gray round button you can see here, and there is a fan icon on it. I've created a text area and I set it to show speed. Another text area low, and I set the color to green, and another text area here and I wrote here high, and I set the color to red. There's just one interaction and it is related to return button. Whenever it is pressed, it changes the screen and it goes back to a kitchen screen. I've set the transition to slide and the transition direction is set to south. This is one of the most interesting screens that I've created. I used this image for the background, which you can see here. I've set a digital clock here, a toggle button for controlling the lights. You can turn them on and off. I have used these two images for the lights. I've set this image here so I could place text area here. This image. I've also placed another image here, which is a symbol of degrees of centigrade. I've set a text area here. In fact, this text area is going to represent the temperature in degrees of centigrade. I created a wildcard. I set its initial value to 100. I checked use wildcard buffer and I set the buffer size to 10. I set the typography to oven temp. In fact, by default, these three typographies exist in TouchGFX, but I created this typography on my own by going to Texts, Typographies, creating a new typography. I called it Oven Temp. I set the font to Arial, the size to 20, and I set the wildcard ranges to 0 to 9 because I just wanted to represent numbers with this text area. I created a flex button here. It is for increasing the temperature. Flex button 2, it is for decreasing the temperature, and you can check its images. I've used these two images. One of them is for when it is released and the other one is for when it is pressed. A return button and a toggle button for turning the oven on and off. Let's check the interactions. I created an interaction. I set the trigger to button is clicked. When the flex button 1 is clicked, which is this one, I set the action to call new virtual function, and I set the function name to incTemp, which stands for increase the temperature. Another interaction is created. The trigger is set to button is clicked, and whenever this flex button 2 is clicked, this interaction is called, and I called it decTemp, which stands for decrease the temperature. And an interaction for returning to kitchen screen, and its source is return button as usual. But to be able to control these temperature with these buttons, we need to write a little bit of code. Let's see how I managed to do that. In CubeIDE, I opened Oven Screen Presenter. I went to HPP file. I declared two virtual functions, and their names is exactly the same as what we wrote in TouchGFX software. I mean the function names. One of them is for increasing the temperature, the other one is for decreasing the temperature. I've also created a variable and I initialized it with 100. In fact, this is the value which is going to be shown on the screen. Excuse me, I wanted to say I need to open Oven Screen View.cpp. The headers are the same. Here you can see what you already saw. And in Oven Screen View.cpp, I declared the body of these functions. First, I created the increment temperature function, and whenever that button is pressed, which was flex button 1, the temperature value is increased by 10 units. And whenever it increases 500, the temperature is set to 500 so it doesn't exceed it, and it doesn't show a value of more than 500 degrees of centigrade. These two lines of code is responsible for passing this temp variable to our text area. The same thing is done for decreasing the temperature. Whenever the flex button 2 is pressed, this function is called and it decreases the temperature value by 10 units. And of course the temperature cannot be a negative value, and we pass the temperature variable to the text area and we can see it on the screen. And our final screen is fan screen. I created a box. I set its color to black. As usual, a return button, an image. In fact, it is demonstrating the temperature of the bathroom, and a toggle button for turning the exhaust fan of the bathroom on and off. The pictures used for this button is this power icon, and this power icon. I've created interactions which is related to this return button, and it goes back to bathroom screen whenever it is pressed. Then I was able to generate the code which is responsible for creating the graphical user interface. And after doing the changes that we already discussed, our program is ready to be built and downloaded on our microcontroller. Here is the demo result of designing a graphical user interface for an IoT smart home application. With this system, you can monitor different sections of your home and control appliances with ease. If you found this project helpful, don't forget to leave it a thumbs up and subscribe to our YouTube channel for more electronics content. Good luck!